All right, so let's find equations of linear models. I'll give you a second to read through this. You might want to hit pause. All right, so in this problem, we are looking at discretionary spending of college students. And discretionary spending is spending that is not necessary. So we're talking about anything besides tuition, your housing, and your textbooks. So maybe like gas, entertainment, things like that. All right, and this says we're going to let S be the total college student discretionary spending in billions of dollars in the year that is T years since 2000. So what you should be thinking about is which one is my independent and which one is my dependent. And remember, most of the time, 99.9% of the time, if you have years or some version of time as one of your variables, then that is going to be your independent variable. So we're going to let T be our independent variable and S be our dependent variable. Okay, so check out this table real quick, and then I'm going to let the textbook plot these points for us. And remember, we are talking about years since 2000. So for 2006, they're going to do 661. Plot that point. And remember, 2007 would be 7, and then 63, and then we've got 8, and 70, and so on. Okay, so the black dots represent, which I'm now kind of coloring, let's say pink, represent the ordered pairs from the previous table. Now, whenever you are drawing a scattergram, notice how these dots are not perfectly linear. And in real life, most things aren't perfectly linear. But if they have a relationship, a linear relationship, then you can see a trend. And you can see that as years go by, or as years increase, then so does the discretionary spending. It also seems to be increasing. So what you would want to do if you were wanting to come up with an equation for this data, you would try to find two dots where you would have approximately the same number of dots above the line as you do below the line. Now we have 1, 2, 3, 4, 5 dots. So if we pick 2, then we're not going to have exactly an even amount because there aren't an even amount of dots. So what we do have, notice with the red one, the red line, this line right here, that if you were to draw your line through these two dots, then all of your other dots or all of your other points are above the line. So that is not a good model. Okay, so now check out the blue line. If I use the ordered pair 1076 and the ordered pair 661, then I have I do have 2 dots above the line, and then I have 1 dot below. And that's really the best that we can do with this set of data. But now that we have 2 dots, we can use those 2 dots to find the slope, right? So let's take a look at that. So I'm going to use the point 1076, and I'm going to use the point 661, and I'm going to find the slope and the y-intercept of this line. So my slope will be 61 minus 76 over 6 minus 10. So 61 minus 76 is what? Negative 15. And 6 minus 10 is negative 4. So with word problems, typically we turn our slopes into a decimal. So that's what I'm going to do. And I get 3.75 is my slope. All right, so now with that information, I can use either one of those points and I can find my y-intercept or turn this into slope-intercept form if I use the point-slope formula. So that's what I'm going to do. I'm going to use the point-slope formula. And I'm going to plug in, let's say I use this point right here. I'm going to plug that in for y sub 1. I'm going to plug this in for x sub 1. I'm going to plug this in for m. So I've got y minus 61 is equal to 3.75 times x minus 6. Now I'm going to distribute. And I get minus 22.5. Okay, so now I'm going to add 61 to both sides. And I'm going to put this up here. So y is equal to 3.75x plus 38.5. So there's the equation of this line. So you can see the textbook came up with the same answer as us. They went about it slightly different, not greatly different, but if you'll notice, they used the point slope formula instead of the slope-intercept form instead of the point slope formula like we used. And they did their slope using the other point first, which is fine. We came up with the same slope. We came up with the same y-intercept. It was just done two different ways. So if you didn't notice that, you might want to go back and take a look. Okay, so now on to our next problem. So in this problem, we are worried about our privacy issues. And so it says the percentages of Americans of various age groups who consider their home address to be personal information are listed in the table on the next slide. Let P be the percentage of Americans at age A years who consider their home address to be personal information. Now, this one's probably not as obvious, but we are dealing with a version of time. Years is time. So in this problem, A will be our independent, and P, the percentage of people who worry about this, will be our dependent. Okay, so notice in this table how there are 3 columns. We only need 2 of these columns in order to graph our data. So this column right here, this age group column, is giving you an age range. And if you'll notice, the median age is 21. Same thing with this one, same thing with this one. So these are actually the 2 columns that we're going to be plotting on our graph. Okay, so here's what the graph looks like. Notice how the blue dots are the points that they used in order to create their line of best fit. And notice how they have really 2 more that lie pretty much on the line, and then they've got 2 more, one that lies above and one that lies below. So this line is a great representation of what's going on with this problem. And if you'll notice, the line is declining, so we can expect that our slope should be negative. So using these 2 points right here, we're going to find our slope, and we're going to find our y-intercept, and we're going to write the equation of this line. So my slope is, and so I am using, let's see here, 67 and then 84, and then I've got 59.5 right here and 21. So whenever I do this math, I get negative 17 right there, and I get 38.5 down there. Now, notice how you have a decimal within a fraction. A lot of times your calculators do not like that. So what you would need to do, you need to simplify the numerator, you need to simplify the denominator, and then at the very end, you want to divide. So I'm typing in negative 17 divided by 38.5. And I get negative, I am going to round here, so I'm going to give it 2 decimal places. So it's approximately. I'm going to change that equal to an approximate sign. So now that I have my slope, I can start writing the equation of my line. I'm going to use the point 2184 as my x sub 1, y sub 1, and my negative 0.44 as my m. So I've got y minus 84 is equal to negative 0.44 times x minus 21. And now I'm going to turn this into slope-intercept form. All right, there we go. There's our equation of the line. Y is equal to negative 0.44. Ooh, look what I did. I left off my x. That's important. Don't forget your x. I do take off points for that. Negative 0.44x plus 93.24. All right, so this is it for today. I hope this video helps. Make sure you send me a message if you have any problems at all.